13-5 quadratic applications. Remember, it is arrows and areas of rectangles. Here we go. The area of a rectangle of a piece of cardboard is represented by the equation that and that equals 9, where W is the width of the cardboard. Find the width. So we are going to W times 2W plus 3 equals 9. 2W squared plus 3W equals 9. Turns out to be a quadratic. Need to set it equal to 0. 2W squared plus 3W minus 9 equals 0. This is my A, this is my B, this is my C. Factors of 18 that negative 18 and the signs are different. I can do that by tic-tac-toe. So I'm going to do 2 and negative 9 and negative 18. The signs are different and I have to get a positive 3. And the larger, that's 6, that's negative 3. That gives me the 3. Factors of 2 and 3 are 1. That's negative 3. That's 2. That's 3. My factors are 2. X minus 3 equals 0. And, 2x minus 3 times x plus 3 equals 0. Those are my factors. 2x minus 3 equals 0. And x plus 3 equals 0. I have 2x equals 3, x equals 3 over 2, and x equals negative 3. But this, actually, they're w's. W is width. That one does not work because you can't have negative lengths. Doesn't work. So your answer is 3/2. If you get good at factoring and noticing stuff, so when I was doing this and I looked, I was like, oh, hey, that's negative 18. So that's, signs are different. To get positive 3, my brain automatically went to 6 and negative 3. I didn't use quadratic. If you used quadratic, you would still end up at 3/2 and negative 3, where you can't have a negative 3 as a length, so your answer is just 3 over 2. Parks Commission wants a new rectangular sign with the area of 25 meters squared for the visitor. The length of the sign is to be 4 meters longer. The length is to be 4 meters longer than the width, and W equals width. So it is the area. Yep, area. So I have W times W plus 4 equals 25. So I have W squared plus 4W equals 25. Can't solve quadratics unless they're set equal to 0. One and 25, 5 and 5, not going to get to 4. Have to do quadratic. This is my A, this is my B, this is my C. Opposite of B plus or minus B squared minus 4AC all over 2A. Negative 4 plus or minus 16 plus 100 all over 2. Negative 4 plus or minus square root of 116 over 2. Make sure you have that all over 2. Don't just divide the square root by 2. Negative 4 plus square root of 116 over 2 and negative 4 minus square root of 116 over 2. This is 3.4. This is negative 7.9. In quadratics, that is a solution. And real-world application, my variable is width. I cannot have a negative width. That gets crossed out. So I have 3.4 is width. And this is 3.4 is the width and 7.4 is length, because I'm adding 4 to the length. So this is your final answer. And that is the second part of solving quadratics. Applications with arrows in areas of rectangles and all other sorts of quadratic problems.